Hola amigos! Welcome to this new Unreal Niagara tutorial, where we're going to be building this fully customizable firework system from scratch. But before we begin, if you do a quick search for Niagara fireworks on YouTube or Google, you will find plenty of tutorials and examples, but we are going to do things quite differently from those. You see, a lot of those tutorials make the entire effect in a single Niagara system. While there is nothing inherently wrong with this approach, and to be honest, it can be an easy way to learn about event handlers, my method is a bit more complicated. We will make this from scratch in a moment, but there are two main aspects to it. First, we have a couple of blueprints that hold the configuration and run the fireworks logic. And second, a series of separate Niagara effects that we attach or spawn from those blueprints as we need. And there are several reasons to do something like this. Let me stop this so we can show you. The first is usability. The UI for a blueprint is way easier to use than the Niagara editor. I could give this to a level designer or a texture artist, and they should be able to configure and make really cool firework displays. However, if I give them instead a series of Niagara effects, well, first they will need to learn how to use this editor, and that just adds another step and that complicates the process. You could even make a custom UI editor widget to make it even more user-friendly if you want. Here, I have all the controls for the fireworks visuals separated for explosions, rocket trails, lights, and rockets, and I can even test them in the editor if I want to see them in the scene. Let me show you that. I can go here and select this one. I think it's this one here on the left, and just see how it looks. And that's pretty cool, but let's say now I want the color of the outside explosion, because it has 3 layers, to be yellow. Let's see how it looks. Yeah, that's much faster than going to Niagara and making changes to this specific particle effect and whatnot. Next is scalability. If I have to make copies of these fireworks and make a bunch of them to create a display, it's way easier and it's a lot faster to edit if I'm using a blueprint-based system than just spawning copies of the effect and trying to edit them manually and one by one. As an example, this show that I made at the beginning took just a few minutes to edit in Sequencer. And it's just a series of start and stop events for all the different fireworks, at least those that repeat. Another aspect of scalability is that since the blueprint system is already taking care of setting the Niagara parameters, adding new explosion or trail types is much easier and doesn't require a lot of work. For example, I have 6 types of explosion, and I think I made 2 types of trails, and adding more will take just a few minutes. And finally, and this is my main limiting factor, is that if you do this with both the rocket trail and the explosion in a single Niagara system, you're almost forced to use CPU particles, since event handlers are not compatible with GPU systems. There are potential workarounds, but nothing simple, so if you wanted to do something like this one, let me find it, I think it's this one, where the fireworks arrange in a specific pattern that I'm taking from a texture, that type of effect is very complicated to do using CPU particles, because the main module that we use, which is sample texture, is not compatible with those. And this way, by separating the trail, the rocket, and the explosion, not only we can use both GPU and CPU systems, but it is also much easier to mix and match different effects or even layer them up, as you can see I'm doing here with the explosions, and we can add as many layers as we want. Since this is going to be a more complex tutorial, it will be divided into multiple videos. In this first one, we will set up most of the blueprint logic, so we can focus on the effects on following ones. Let's start by creating a new blueprint and select the actor class. We can name this one BP for blueprint and Fireworks launcher. Let's open it up and let's think of all the properties that we might want to change in different instances of this object. So we might want to change its visibility, like we might want to put one big launcher and have different series of fireworks coming from it, so we don't need all of them visible. So let's add that one. Launcher visibility. Next, we might want to use different meshes for that object. Maybe one artist has made a box, and then another one has made a little cannon, and another one has made just a tube that has like spirals of different colors around it or something like that. So let's add a second variable and call this one launcher mesh. And change the type of this one to static mesh. Static mesh object reference. And finally, maybe we want some of these meshes to be scaled differently, or maybe the artist that made that cannon made it for a different thing, so we just need to scale and rotate it down. So let's add a transform. So launcher transform and change the type to transform. Okay, so let's make these three visible, so they are public and instance editable, and let's compile and save. Now first, before we go into the event graph and the construction script, we will need a mesh. So let's click add and click on static mesh. Let's call this one C for component and launcher mesh. Now we can click compile, save, and go into the construction script. Note that I didn't make the static mesh the parent of this blueprint, and I kept the default scene root instead. This is important so we can apply transforms to this launcher and not affect the rockets or any of the particle systems. Next, let's organize these blueprints, or these variables, a little bit. Select any of them, and here on the category, let's type something like launcher settings. Now that we have the category created, we can just drag and drop the other variables there. Now let's start by setting this by using these parameters. So drag one of each and get the get for each one. So get launcher visibility, get launcher mesh, and get launcher transform. And we are also going to need one reference to the mesh component. So let's start with the mesh. So from here, set static mesh, and we can drag our variable. Next, we want our transform, so set relative transform, chain link, and connect our variable. And because we don't want to do anything weird with the physics, let's also click the teleport. And finally, set visibility and connect the property, and also propagate to children in case our launcher has multiple pieces, multiple meshes. Now let's connect this here, and we can give it a test. So compile, save, and let's drag one of these here. And I already gave them some default properties, but we can change the visibility and the mesh. Let's keep the setting there for now. And the transform. And note that the object is moving, but the blueprint is still here, so we haven't moved that. If you're curious, I'm using a cylinder, and location offset on the z-axis 50, and for a scale 0.2, 0.2, and 1 to get this long tube center on the bottom. I wanted to center it on the bottom, so if I want to shoot rockets in a different direction, I can still rotate the blueprint, and I don't have to move and rotate every time. Cool. Let's save everything and go back to here. Now the next thing I want to do is convert this into a function to keep things a bit more organized. So select everything and right click on any of the nodes and select collapse to function. And let's rename this one, I don't know, set launcher mesh. Perfect. Now that we have a launcher, we need something to launch. So let's go to the content browser and create a new blueprint. Also the actor class. And let's rename this one to BP Fireworks Rocket. Now we can open it up. And let's also add static mesh. This is going to be our collider, so let's call this one collider. And let's make this one the root. Now this one, let's set a static mesh. Let's take a sphere, just a simple sphere from the editor, and let's click on simulate physics, and simulation generates heat events. And for now, just compile, and actually let's search for let's select just the rocket and search for life to get the initial lifespan. And let's for now just give a constant value, let's say 2 seconds. So after 2 seconds this blueprint will cease to exist. Now before we launch sequences of rockets, we need to learn to launch one single rocket. So let's create a new function and call it shoot a single rocket. Perfect. Now let's go to our viewport for a moment. Right now, if we just spawn our projectile that we created from the location of the blueprint, it will spawn from here. And depending on the location and mesh that you're using in your case, maybe you want the projectile to come from here or from here or somewhere else in the vicinity of this mesh. So we'll need a vector that we can apply as an offset to this location. Next, we also probably want to disable collision with this object. So let's go back to our Fireworks launcher, select the mesh, and here on the collision presets, let's change it to no collision. You could change this to have no collision specifically with the projectiles, but I'm going to simplify things because in my case, all these launchers are very small and won't be a problem if objects don't collide with them. So let's create that variable and let's call it launch position offset and set this one to be a vector. And we'll apply this to all the rockets, so let's put it also in the launcher settings category. So now we need to spawn actor from class and select our Fireworks rocket. Now we need to apply some transform, so let's do that. And let's change also the collision handling to always spawn and ignore collisions, which shouldn't be a problem with our mesh, but just in case. So for our transform, let's start with getting the actor location, because this transform will be in world position. So let's add a vector to this. Now that vector, we want to do it in the orientation of the blueprint, so we don't have to change this offset every time that we move the blueprint. So let's use a get actor transform, and from here let's use a transform transform direction. So this node requires a transform and a vector, and we have our vector here. So get launch position offset, and this returns a vector that we just now connect here to add to this location. And now we can make a transform using this location. Let's also get the rotation, connect it here, and for scale, let's keep it at 1. Let's move all this a little bit to the right. Perfect. So now if we want to test this, we can select the function here, and we can click and call in editor. However, actually, before we do that, let's give some velocity to this object. So set linear velocity. It will automatically add this node to get the collider object that we created. And now to add a velocity, we need to find the direction. So let's do it in the app vector of this actor. Oh, sorry. Get, there we go. Get actor app vector, and let's multiply that by a float. Let's say 1,000, and let's set this velocity for now. Okay, so now we compile and save, and we go back to our viewport. Now we have our shoot single rocket here. However, if I just press it, well, now we have a ball, but it's not really moving because we are not playing. And also this is gigantic, so we'll need to change that in a moment. Now I want this function to work, but only when it's in play mode. And there's not an easy way to find if the editor, if you're in editor mode and within like in play mode or just stop. So there's a little workaround. We can go here and create a new Boolean variable, and let's call this isArm. We don't need to make this public. Actually, we'll make the launch position offset public, and let's change this one to a Boolean. So let's compile, and by default it's set to false. So now when we begin play, we'll set this one, this is armed, to true, and then we can go back to our shoot single rocket and insert a branch here, and only actually create this blueprint if this is armed. And otherwise we won't do anything. Now we can go also to the Firework rocket, and let's change this collider transform or scale to, let's say, 0.1, 0.1, 0.1. Or just click the little log and change either of the values. Now we can try again. So now if we press this button, nothing happens. If we press play and now select our Fireworks launcher and press the button, boop, now we have our little yep, it's pretty fun. Now, because of the way we set up these transforms, if we just rotate this and press play and do the same, shoot the rocket, it shoots in that direction. Now it's shooting in that direction, but from the bottom because we didn't apply an offset. So let's change that. So launch position offset, we know from the transform of the launcher that is 50 units up. Sorry, it would be 100 units up. So let's give it a try. Select it, shoot rocket, pew, pew, and there we go. They're light up for 2 seconds and then disappear. Perfect. Now let's do the sequence. Actually, before we do that, let's give this launch position offset a default value, just to match the same default values that we're using for the mesh and for the transform. And let's also add a couple parameters. So we'll need initial rocket speed, and let's also add another one, and we'll call this one random launch angle, and change this type, or the type of both of them, to be a float. So let's compile so we can give them default values and set the speed, let's say 2000, and for the launch angle, let's say 5 degrees. So now we can get this speed and multiply it for that vector. But also, instead of using that vector directly, let's use this random launch angle that we created. So let's do a random unit vector in cone in decrease. So now this node requires first a direction for the cone and an angle that will be half of that cone's angle. So let's get this property that we just created and then replace this vector here. So we are now shooting these rockets with this speed in an angle that is slightly randomized. And we could also randomize the speed, but I think that's okay. And we can make now these two variables public, clicking here and then drag them into the launcher settings. Cool. Now let's compile and let's give that a try. So we can hit play and let's increase just this angle to a lot, 45. Cool, so now each rocket is shooting in a random direction. Perfect, and they are shooting much farther away. Excellent. Now we can move on to the sequence. So let's create that function and call it shoot rockets. Actually, let's move this to a new category. So select either of them and let's call this launcher controls. And let's move both shoot single rocket and shoot rockets there. Compile and save, and let's work on this function next. Now, before we add any nodes, same as we did with the launcher mesh, let's think about the properties that we might want to change on every one of these instances that we create in the world. So first, if we are going to shoot more than one rocket, we need to determine how many rockets we want to shoot. So let's call this number of rockets launched. And we don't want this to be a float, but an integer. Now, if we're shooting more than one rocket, we might need a delay between them. So let's call this one delay between rockets. And this one can be a float. We might have a 0.1 second between rockets. Now, let's say that we also might want an initial delay. Initial sequence delay. And maybe we want the sequence to loop, like shoot 5 rockets every 0.1 second and then wait 5 seconds and then do it again. So we'll need a delay between sequences, and another one. This will be a boolean and we will call it um, uh, sequence loop. Maybe sequence loops, and change this to a boolean. Now let's organize this a little bit. So actually I'm going to move this initial rocket speed to a new category that I'm going to call rocket settings. And then maybe number of rockets launch is here on the launcher, because we also have the launch angle, and then all these delays are part of the launcher settings. We could maybe add a category that was like timing or something like that, but I think that this is going to be fine. Now we have this is arm. We're going to need a few more variables, but actually first let's make all these ones publicly editable. So let's click on the eyeball on each one of these, or click on instance editable here. Now let's create a new boolean and call this one is active, and let's actually create another one called is looping. We will need another one called last launch time. This one will be a float. I will explain all these variables in a moment. And I think that's, oh no, I think we'll need another one. This one will be an integer, and we'll call this one current rocket index. Okay, so let's compile. And so isArm, we already saw that one. IsActive will be used to know if the sequence has been activated, if the launcher should be in shoot rockets mode or not. Then isLooping will be used to know if it has gone past the first sequence and it needs to go back to sequence to the start. That will allow us to differentiate between the initial sequence delay and the delay between sequences. Last launch time will be used to store the time in seconds, since the game in game seconds or in system seconds of the last time that we launch a rocket. That is because if you try to add a delay here, like, hey, let's just add a 4 and shoot a rocket and then add a delay. If we search for delay, there's nothing here. The delay is only available in the event graph, because here's where we have where we're actually running the game tick. These functions don't run the same way, so delay is not accessible. So we need to store the last time that we shoot a rocket and then compare it with the current time. And then current rocket index, oh, I forgot to change this one to an integer. This will be used to store the number, the current index of the rocket that needs to be launched, or the previous one. We'll see that in a moment. So let's actually give all these ones a new category, just to be clean, maybe general. And all of these are going to be used only in the blueprint internally, so none of these need to be visible. Now, for the shoot rockets, let's first do a branch, and let's do the same thing that we did on the shoot single rocket, which is check if this is armed. Perfect. Actually, did I make this public? So select shoot rockets, no, and check the call in editor. Now, if this is active, we will just set the launch time, or the last launch time, to right click and search for get time seconds. And finally, we're going to set the variables is active to true, and the is looping to false. Perfect. So that's what the shoot rockets function is gonna do. Just check if this is armed, so we don't run it when the game is not running, and if it's armed, then just set the is active boolean to true and set is looping to false, and set the last launch time to the current time. So we quote unquote reset the clock. So let's go back to the event graph and let's use this. So here's what we're gonna do in the event tick. So let's do a branch first, and here we're going to compare a couple values. First, we need to get this is active, but then we're going to add boolean. Oh, no, not ADN, and boolean, and we're going to use a new function. So let's create a new function, and we can call this one check launcher timer. Now click on the function name, and here on the properties panel, click on pure, and we don't need to call this in editor, but we need to add an output to this, so it will be a boolean, and we can call this can launch. We'll come back to this function for a moment, but let's go back to the event graph here, and then drag one of these check launch timer here. And as you can see, it's one of these green functions that doesn't have a connection, like an arrow connection for the execution. So we can connect it here, and now if it's active and if the launcher timer has expired, then we'll do the shooting of the rockets. Now, if this is true, we can now just call our shoot, oh no, not this one, we can call our shoot single rocket. So let's connect that, and we will need to update this sequence and see if the sequence needs to reset to 0 or something like that. So let's also add a new function and call it I don't know, check sequence, or maybe update sequence. Perfect. This doesn't need an output, so go back to the event graph and connect it here. So now in every frame it will check if the launcher timer has expired and if it's active, and if so, we'll shoot a rocket and then check the sequence to see if it needs to stop or if it can go on. Now let's compile and let's edit all these functions next. Let's go to the shoot single rocket first, because we need to add a little thing here. So every time that we shoot a rocket, we need to update this last launch time to be the current time. So set this last launch time to be, again, like we did before, get time seconds. Perfect. So now every time that we shoot a rocket, we tell the launcher the time that it happened. So go back to the event graph, and next let's do the check launcher timer. So let's make a bit of room, and actually let's just disconnect this. So let's focus on the return here for now. What we want to do is compare the current time, so get time seconds, and compare it with the last time that it was launched and the delay between launches. So let's add a new variable, but it will be a local variable to this function. So click here on this plus icon at the bottom, and it needs to be a float, and we can call this temp delay time. So let's get this one as well, and let's also get the last launch time. So let's say that the last time that we launched a rocket was at second 1, and we want a delay of 3 seconds between rockets. So the launcher can launch again after second 4, which is the last launch time plus the whatever delay we want to use between rockets. So let's do an add, and now last launch time plus this. So if the get time seconds is greater or equal than this, then we can launch. Enough time has passed between now and the last time that we launch. Now, the reason I added a temp variable here and didn't compare with any of these is because we have different delays. We have the delay between rockets, and we have the sequence delay and the delay between sequences if we are looping, so we need to check with a different time depending on some conditions. So now that we have our output, let's do all this branching now. So let's start with one branch. And let's see if this is the first rocket. So for that, we can just compare the current rocket index. So get this one, and let's do an equal. So if the current rocket index is 0, it means it is the first rocket. So let's make some room and add a little comment that says first rocket. Now, if this is true, it can be for two reasons. So let's add a branch here, and we'll come back to that in a moment. But if it's not the first rocket, it's pretty easy. We just need to set this temp delay time. So set it to the delay between rockets. So, which means that, select these two and add a little comment box and say second plus or greater than second, greater or equal than second rocket. Perfect. So if it's not the first rocket, we just use the delay between rockets. Boom, and return. Now, if it's the first rocket, it can be for two reasons. So if it's already looping, get is looping, it means that we are on the second loop or third loop or fourth or whatever. So we need to use the delay between sequences. We could have called this between loops, but whatever. Get delay between sequences, and if it's false, if it's not looping, it means that we need to use the initial sequence delay. So let's get that one, and two of these sets set for temp delay time. One, and we can copy paste. So if it's false, the delay that we're using is the initial. If it's true, it's the delay between sequences. And again, just to be a bit cleaner, let's give some comments, put some comments here and there. So this one will be first loop, and this one will be greater or equal than second loop, and all this will end up in the same return node. Cool. So now we are checking if the launcher can launch. We can compile, save, go back to the event graph, and if we can launch, let's shoot a single rocket, but next we need to update this sequence, which will be updating this current rocket index and a couple more things. So, in this update sequence function, the first thing that we want to do is update the rocket index. So let's get this one, and we don't need to add 1 to it manually because there's an increment int. So current rocket index plus plus gives us +1. Now, if this we need to compare this number to the total number of rockets launched in the sequence. So if this number is less, not less or equal, because our sequence starts at 0, if this number is less than the number of rockets launched in a sequence, so if, let's say, we need to launch 10 rockets, so until rocket index is equal to 10 or is equal to 10, this will be true. So let's branch this, connect this here. So if this is true, that's it. We don't need to do anything else. We just add +1 to the rocket and keep shooting. So we can add a return node. Now, if this is not true, that means we've reached the end of the sequence. We need to do things. So first, let's reset the current rocket index. So set back to 0. Next, we want to branch. And depending on if it's a sequence that loops or not, we will do a couple different things. So get sequence loops, connect it here, and then if it's true, we just set the isLooping variable to true, because now we are in the loop. And if it's false, we just need to deactivate the launcher. So set active to false. And then a return node. And we can reuse the same one. And that is our update sequence function. So let's compile and save and make sure that everything works. Now make sure that your default values make some sense. So number of rockets 1, delay between rockets 0.1, initial 0 between sequences 1, and it doesn't loop by default. That will work. So compile and save, and let's give this a go. Shoot single rocket still works, and shoot rocket should only shoot 1. Let's do 5 rockets, and there's 5, and now let's do 10, and let's do it faster, 0.05, and let's wait 2 seconds for the first one, and then 1 second for the rest, and make it loop. So 2 seconds, and then it goes and shoots 10, and then another 10, and so on. Now, we don't have a button to stop, so let's fix that next. Let's stop that, go back to our blueprint, and here we can add another function, call this stop shooting. And we can move this to the launcher controls and call in editor. So this one is very simple. We just need to set isActive to false. Now we can give this a go if we want. So yeah, let's say 10 rockets, and it loops, shoot it, and now stop, and it stops. Perfect. Now let's go back to some of these functions. Let's go to this one, shoot single rocket, and add some comments to make things more clear. So here's where we're setting the rocket transform. So we set the rocket transform, and then let's make some room here like that, and here's where we're setting the rocket initial velocity. Perfect. Now the last thing I want to do is pass to the rocket the last 2 properties that don't affect the visuals, that they're not visual properties, which are the duration of the rocket, the lifespan, and a delay between when the rocket stops emitting its trail and when it explodes. You might have noticed that sometimes in fireworks there's the rockets that explode and kind of immediately after the trail kind of stops, but sometimes there's like the trail, and then a second later the big explosion, right? We'll add that as a second variable. So let's first add those variables to the rocket. So let's create 2 float variables. The first one is going to be rocket lifespan, and the second one is going to be the rocket the explosion delay. And we can compile and give this some default value. So by default, let's say rocket lifespan will be 1 second, and then delay 0. Perfect. Now we want to make these 2 public, but we also want to expose them on spawn. So click here for both of them. That means that when we go back here to the spawn actor, where we spawn this rocket, the compiler or the editor will be smart enough to show those properties here in this box. However, this doesn't work always at the first try. So here you see I compile, save, and it only worked the second time that I compile and go back to this other window. So just go back and forth a couple times and recompile if you don't see the new parameters. So now let's create those same parameters here. So again, two floats. First one, rocket lifespan, and second one, explosion delay. Explosion delay. Now we can move the rocket lifespan to the rocket settings, and let's create a new category for this one, explosion delay. So let's do explosion settings. Perfect. Now let's compile, also gave them default values, so rocket lifespan, let's say 1 second, and explosion delay 0 by default. And then let's connect them here. So rocket lifespan, there it goes, and explosion delay here. Now we need to use these variables, so go back to the rocket, and here in the construction script we want to use those to set the lifespan of this blueprint. So just drag and set lifespan. The actor lifespan, not our variable. Now, this is when the lifespan of the actor expires, it will be destroyed. So this will need to be equal at least to the rocket lifespan and the explosion delay. So if our rocket lasts for 2 seconds and then there's another second of nothing and then explodes, then that's 3 seconds total. However, if we just connected this here to the lifespan, what would happen? Let me pull back here and show you one of my rockets. Let's say this one. And let me pause and go frame by frame, or a slow motion, slow-mo 0.1. So after it explodes, the trail is still visible, and the particle trail for this rocket was very short, but it was still visible for a moment, right? Now the problem is that if you destroy the actor that this particle effect is attached to, and we have to attach the trails to this actor, then the particle effect will be also destroyed. So let's give this actor a little bit of extra time as a buffer to give enough time for the particle effects to disappear. So let's take this time that we are getting by adding the lifespan and explosion delay, and let's do, I don't know, times 2. Times 2. So let's compile and save. And that means that, let's go back here and hit play. So where is our launcher? Is here. And let's say we want, oh, we didn't make these variables public, did I? Here, no, I didn't. So rocket lifespan, public, and explosion delay, also public. Now, if I select this, and let's say, yeah, let's say 500 on the speed, just so it bounces here. Let's say 2 seconds lifespan, 1 second of explosion delay. So here's what happens. We shoot a rocket, and 1 second or 2 seconds later, the rocket will stop emitting the trail. But there might be still some lingering smoke or some lingering sparks here in the trajectory of our rocket, right? So at 2 seconds, we just stop the trails, and we will also add a flare effect for the rocket. We will also stop that particle effect. And then 1 second later, we will spawn all the particle effects that constitute our explosion, and then a little bit of time later, we will destroy the actor. And hopefully, by that time, all the particle effects that were attached to it, which is the trails, will also have dissipated. And that's how our effect more or less is gonna work. Let's end this first chapter in this tutorial series by adding a little bit of pizzazz and one actual explosion effect to our Firework rocket. So let's go to our rocket blueprint, and we're going to add a couple of Boolean variables. One is going to be is trail active, and the second one is going to be called is unexploded. And let's compile and save, and by default it's trail active, let's set to true, and is unexploded to true as well. So by default our rockets will be active and will have not exploded. Now let's do a branch, and first let's check if the rocket has needs to deactivate the trail, because that usually will happen first. So let's get this, and let's get it's called game time since creation. So this is the time since this blueprint has been created, which is perfect. So if this is greater than our rocket lifespan, which is here, and Boolean, and the trail was still active. So if this statement is true, it means that we need to deactivate the trail. So for now, we'll just set this later. We'll complicate this later once we add actual VFX. But for now, let's just change this boolean to false and make this sphere that we're using for now invisible, just to represent the trail disappearing. Next, if either this is true or false, we need to compare the explosion time. So we're going to also get the time since creation, but this time we're going to compare it to the rocket lifespan and the explosion delay. So let's add these two together. And if more time has passed than the explosion delay plus the lifespan, then let's explode this rocket. So let's create a new function, and let's call it explode rocket. And going back to our event graph, let's branch this. Branch. So after we set the visibility, or after we don't check this because the rocket is already deactivated, we check for the explosion delay, and if it happens, then we'll just call this function for now that is called explode rocket. And let's add a little bit of explosion effect here. So let's do spawn system add location. There we go. So let's select, I think there's something here by default. Yeah, let's select the radial burst, which is one of the templates that Niagara comes from. comes with. Sorry, it's on the Niagara default assets templates. So we'll just use that for now. And we need a location for that. So let's find the location. So we need the location of this collider. So get world location. And just connect it here and auto destroy, auto activate. That's all good. Let's compile and save. And this should work. Oh, actually, let's... Oh, I forgot one more thing. We also need to check if this is unexploded. Otherwise, we would explode it constantly. Oh. And boolean. So here we were checking if the trail is active, then we deactivate it. Then here we check if it's unexploded, and if so, we also set this to false. It has exploded. Now we should be ready to play, and let's see if this works. Yeah. So as we can see, the object disappears, is still there, falling but invisible, and we get a little explosion. So let's do 10 rockets and 0.05, and let's make it loop, and there we have it. Actually, let's stop shooting and let's increase the random angle to maybe like 25. There we go. So this is a start, but in the next video we'll add some trails, both sparkles to make it more colorful, but also a lit smoke that will be illuminated by the passing rockets. And that's it for this one. I hope you guys enjoyed it, and if you did, please consider subscribing and hitting that like and that notification button. It helps a lot. See you next time.